Hello. What I want to do today is go over some of the problems from daily problems number 23 that we didn't have time to do in class. These are ones that we talked about on learning catalytics, or at least you answered questions on learning catalytics. And these are some of the ones that the fewest number of people got right. Again, more than half of you got these right, but definitely worth going over because these were between 50 and 60% correct. So these are from problems number 2 and number 3, again, daily problems number 23, which we talked about on April 18th. So the first two are from problem 2 and the second two are from problem 3. So what I want to do is just give you my strategy for approaching these sorts of problems. So the first one, for problem 2, compare these two molecules. They were labeled 1 and 4, and then compare these two molecules. They were labeled 3 and 5. So some of the strategies we talked about in class, you can build one of these, then manipulate it and see if it looks like the other one. Obviously, you can build both of them and try to see if they are the same diastereomers, enantiomers, constitutional isomers. You can label centers as R and S and see how they compare to the other molecule. What I'm going to do is just do manipulation of the structures so that we can see how, without using R and S and without building a model, we can actually answer these questions. So when you get a problem like this where you have a chair conformation and a perspective drawing, it's much easier to figure these things out when you're looking at the perspective drawing. So the first thing that I do is to convert the chair into a perspective drawing and then compare. Right? So what I would do is just say, all right, over here, we're going to convert to that perspective drawing. Right? So I'm going to put the oxygen up top. And again, what we said when we were doing this, back when we were doing chair conformations of cyclohexane, groups that are pointing down go back, so they're on a dash. Groups pointing up end up on a wedge coming out at us. Right, so we can work our way around. So here we go to there on a dash, it's up, that's on a wedge. Next one's up, that's on a wedge. Right, so we get to something that looks like that. So now we get to compare those two, right? So now we have to start doing a little bit of manipulation to figure out what's happening with these. What you can do is to rotate so that you get the oxygens in the same orientation. So let's rotate. And what I want to do is get the oxygen, let's rotate in this direction. I'll put the oxygen down here. We'll see if it's a mirror image. So if we rotate to put the oxygen down there, we're going to get that, and then the OHs are here and here. And again, when you rotate, none of the wedges turn into dashes. Wedges stay wedges, dashes stay dashes. So we've just rotated this a little bit in that direction, right? So if we compare these two, right, it looks to me like all the bonds are opposite. But the key here, and this is often where people make a mistake on this one, what we need to do to actually see if these things are the same is to take this and pancake flip it so that the oxygens line up. Because right now, it's oriented these two as if they were mirror images, right? And everything's opposite as the mirror image, right? So that means there's something weird going on here. So what we need to do now is pancake flip. All right, so we're going to take this and flip it that way, right, so that the oxygen will end up in the exact same spot as it does over there. And if we do that, again, take this pancake flip, all the wedges become dashes and dashes become wedges. All right, so we pancake flip like that, right, so that group ends up over here, coming out. Right, that group was going back, flip stays in the same spot, it's coming out. And then all the rest of them are going to be dashes, right? So that's that one, OH, OH. So now if we compare these two, they're the exact same thing, all right? So we had to do a little bit of work to get there, but these things are identical. Okay, so that's this problem. Thing for this, convert this chair into a perspective so that we can then compare to this structure. Right, so let's put the oxygen in that position. Right, and we'll work our way around the ring. So that's down, that's up, that's up, that's up, and that's down. Okay. So we're pretty close on this one, I think. All right, so let's just do a slight rotation. So what I want to do is rotate just a little bit to get the oxygens to line up. So we're going to rotate like that. So let's put the oxygen in that position. And let's see what we get. Now if we compare these two, right, the oxygens are in the same position, right, so oxygens both oriented in the same way. And then if we work our way around the ring, right, wedge, dash, dash, wedge, dash, wedge, dash, wedge, wedge, dash. It's exactly opposite, right? When it's in the same orientation and everything is opposite, that's the enantiomer, all right? So these two things are enantiomers. Again, non-superimposable mirror image isomers for the enantiomers, right? And if we wanted to, we could take this thing and flip it over and line it up next to this, and it would show the mirror image, and it would be the exact mirror image, okay? So this is a good strategy for trying to figure these things out if you don't use a model kit and you don't use RS. If you practice this, you can actually probably do it quicker this way than figuring out RS or using a model kit. Okay, so let's move on to problem number 3. So for problem number 3, we were given this molecule in a box, and we wanted to figure out whether these other molecules were constitutional isomers, identical enantiomers, diastereomers, right? And so 1 and, what was this one? 1 and 4 were the molecules that we struggled the most with. Again, more than half you got it right, but these are the ones that we should talk about. So let's take a look at these and see how we can compare. Right, so if we look at this molecule with respect to this one, I think what we need to do is to do a rotation, and then we can compare. The way that I think about this is just trying to line up the F's. Right, so the F is the thing that's the most different, so I want to rotate this so the F is in the same position as this one over here. Right, so let's do a rotation. And for this rotation, I want to spin this around so that the F ends up in that spot. So let's just do that. So we'll rotate it around. And again, when we rotate in the plane, right, all of the wedges stay wedges, dashes stay dashes. So if we want the F to end up here, it's going to look just like it did. So if the F ends up there, then right next to it is the methyl and the chlorine. And then right in front of the F is the OH and the H. And again, if this doesn't come easily to you, make sure you number the carbons so you get everything in the right spot. That's a common mistake, is not numbering things. Then you rotate it or flip it and things move around. You don't want things to move around. You want those bonds to stay exactly where they are. All right, so now we can compare these two, right? And if you look at these two, if you look at every position, so here, methyl and chlorine are opposite, the fluorines are opposite, OH opposite, OH opposite. So everything is opposite comparing those two. Again, if everything is opposite, these things are enantiomers. All right, enantiomers. Okay, so again, same sort of strategy that we used above. This time we only had to do a rotation and we were in good shape. Right, so let's look at number 4 and see how we can do with that one. All right, again, I would like to get the F's in the same position. It looks like to me that doing a rotation isn't going to do it, because if we rotate, we're going to have the methyl down and the OHs are going to be up. We don't want that. So what we need to do to get the F in the right position is to flip this. Right, so let's do a pancake flip right? Again, taking the molecule this way and then flipping it over here, right? So that will take all of the wedges and turn them into dashes and vice versa, right? So the F is now going back. The CH3 was out. CH3 is going back. Chlorine is now coming out. So we flipped it this way, right? So this OH is going to end up here, coming out. Right? And this OH over here, flip it, it's going to end up going back. So we can compare these two things, and if we do that, they're identical. Right? So these things are the same. Okay? So hopefully that gives you a good idea of how to do these sorts of problems. Again, it takes some practice, but we should be able to do this, right? It's good practice to get into rotating these structures in the plane, doing pancake flips, things of that sort. Again, going from chair conformations to perspective drawings. So anyway, I hope with practice that we're in good shape doing these sorts of problems moving forward.